So this is a power supply I made a couple years ago. I didn't have a bench power supply or anything, and to be honest, I just wanted something I could carry around with me and have a variable output, have a voltage display, an ammeter, power output display. I want to know how much energy I'm using. I wanted all these features on it. I wanted rechargeable batteries, you know. And so I made this. This has two voltage outs, so it has two converters inside of here. It runs off of four 18650 batteries, so high capacity. Right now it's four 2600 milliamp hour batteries, and the way it's configured is with this switch right here. I know it's very messy. I'm planning to either rebuild it or just fix up the aesthetics here. It's due for some maintenance. I have to replace one of the converters inside of here. Yeah, I was using it to charge a lead acid battery, and it was a little too much current, I guess, and it got messed up. It was one of those small sealed lead acid. Anyways, this switch right here, it does something quite interesting. So I originally had four 18650s in parallel. This way I could have also a 5-volt USB out to charge my phone, and so that this whole unit could be charged using micro USB. But the converter has a 3 amp input max, so that only gave me about a little less than 15 watts of power out, and that just wasn't enough. It was about 12 watts or something. So now the configuration it runs in is 4 batteries in series, so I have as much power as I would generally need. And when I switch it down, it puts them in parallel, so I just charge them using RC helicopter balance charger. Because if I were to get a 4S charger, it would be pretty much the size of the unit. I wanted something that made sense. So, for example, I was taking apart an old printer that was laying around, and yes, there is a lot of scraps left over. Yeah. Anyways, as I was salvaging parts, I saw this motor to this and this assembly, and I wanted to test it because it gave me some ideas for possible projects using linear motion. So I wasn't sure, and well, this came in useful again. So with its small size, I had to make my own adapter for it. As 3 alligator clips, ground going through the ammeter, ground without going through the ammeter, and the positive voltage out. And it's all connected to this 3.5 millimeter jack. And just like that. So I could bring these parts to the bench and test them out, but in some cases you can't really do that if there's no space over there, or if there's just some things that are a little too distant and you want to test it on the spot. So by setting the output to about 8.5 volts, I could see that the whole assembly works. And it's quite handy that there's a switch on it too that you can just power on and off. But yeah, that's pretty expected anyways. So if you notice, there's 2 barrel jacks on the side. One of them, so when you have it on, when you flip this switch right here, this light turns on. Now this is a direct connection to the battery, so if you wanted to power, let's say, a car inverter, so if you have cells good enough inside of here, they are removable. They're in battery holders, so you don't even have to charge it. You can just switch out the batteries inside of them, charge them. This way you have this powered at all times. So if your cells are good enough, you could ideally power an inverter and power, let's say, your laptop charger, or it's probably not going to work on larger electronics, but like work lights and stuff like that. So that's pretty much it for that project. And as I said before, I was planning to either rebuild this or make it look nicer. So I do have a few cases, and yes, there is another router. This one looks a little better. And I have this smaller case. It was from a USB tuner. I don't know, whatever works, but to be honest, I kind of like this case. So yeah, I mean, it even has the built-in little standoff, so you can mount this anywhere. Anyways, that's it for this project.